Let me know if you can see my screen, Paul.
I can.
Awesome. So thanks everyone. Before I will hand it over to Paul, I will just like to thank all of your sponsors, because of which this virtual dreaming event is successful. So I will just play a small video, and then I will hand it over to Paul.
We were just a bunch of nerdy kids who ignored the haters. We took their ridicule and we built on it. And when some of us gave up, well, we built on that too. Built resilience, built on a mission to make things a little better every day until the users came. Then the haters were VCs who scoffed at our audacity. This just isn't the way things are done. But we kept building. Users turned into teams, turned into companies, running their entire businesses on our apps. Then the software giants came after us. We weren't proven. We weren't fully featured. Our radical cloud model wasn't secure. But we built on. And today, as companies adopt the cloud to move faster, teams are finding themselves slowed down by each other's efforts. The skeptics are claiming we'll never develop innovation at scale. But now, DevOps have come to the cloud, ushering in a new era of transformation. Companies can release on demand across hundreds of environments, innovating faster with fewer conflicts and fewer disruptions. There will always be challenges. There will always be naysayers. And we'll build on.
Own Backup protects against data loss and corruption by providing enterprise-level control of data across all your Salesforce orgs from a single dashboard. Interactive graphs make it easy to identify Salesforce data changes over time, and automated daily backups protect your Salesforce data, metadata, and attachments. Manage proactively with customizable smart alerts that notify you whenever data is added, changed, or deleted. Quickly search your entire backup archive to find specific records, remove records individually or in bulk, and stay compliant with internal and external regulations, including GDPR. Compare backups at the click of a button to locate the exact point of which data was lost or corrupted, and recover lost data quickly, regardless of scale. With Own Backup, you can restore data records with their corresponding parent-child relationships down to any level of granularity. Speed up development with Own Backup Sandbox Seeding and Replicate to create anonymized test data sets in minutes, while advanced key management and access controls help to keep your data secure. Backup, compare, recover, replicate, and comply with Own Backup for Salesforce.
Great. Okay, well, let me know if I move too fast, wave me off or anything, but if the slides can't catch up, hopefully my connection's good here in the good old Dallas of Texas. Live from my living room or dining room. So quickly, we'll go through the intro slides acknowledging our sponsors. So could not do these kinds of things without them. So everybody, please take a minute to view, and if you know anybody, please thank them for me. These are great opportunities to share information and knowledge and connect with people. So hopefully everybody's having a good time. Thank you, all 60 of you, for staying up this late. All right, and then we've got the slide for the extra partners. And I don't know, Jitendra, if you wanted to talk about what these two do. I had questions briefly about what these nonprofit charity partners were for, but
Sure, Paul.
and then
Yeah,
Mercy Corps.
I can just add one or two lines. So Virtual Dreaming has pledged to support anyone who got impacted by COVID-19. And we are trying to raise a fund of $50,000. Mercy Corp is an international company. And today we already raised around $11,000. So I will say this is a free event. It's a no ticket. But if even every participant can donate just $1, it would be helpful for anyone who is got impacted by the COVID-19. So these are the few partners who has helped us.
Ah, great. Okay, good to know.
Yeah.
All right. Well, so my name's Paul McCollum. I'm a cloud architect at SenseCorp. We're a Salesforce consultancy. We've got my connection information over here. I love to connect and reach out and share information. This presentation is about kind of tips and tricks and or ways to look at projects to make sure that you are architecting them correctly. So it'll be part of a series. but I'd really love to hear horror stories and best practices from anybody as we go through. If you've got an example or a good story, I'd love to include it and incorporate this as we go forward. But I've always been a platform architect. I've been SharePoint SQL Server, Salesforce certified. I hold a master certification in user experience and interaction design from Nielsen Norman. And I've been an enterprise architect for most of my career, probably past 20 years. I started programming in 1978 and have hopped in and out of just about every language. So if there's a computer language out there, I've probably at least written Hello World in it. And that's who I am. I spend a lot of time in Dallas helping run developer groups. I'm associated with the Dallas developers, Salesforce developer user group, run by Moya Sanawala, and I get to work every day with MVP Charlie Prinsloo. So that's a brief about me. Please feel free to reach out if any of this makes any sense to you guys and you want to contribute and or talk about it. So moving on. Another quick thing. Thank you, everybody, for staying home and putting in all of the maddening hours inside of your house and sheltering inside. I have a large number of friends that are at high risk for COVID. So thank you guys for everybody for staying home and participating in virtual events and flattening the curve. All right, so talking about applications in Salesforce, we're really all architects. We all participate in sizing applications to do what they are supposed to do. Now, this is really targeted at the Salesforce solution architect that is moving into the enterprise architecture space. So there are a lot of people that can build applications within Salesforce, pages, buttons, flows, objects, fields, and those are all the core functions that we build magical solutions inside of Salesforce with, but we often need to reach out, connect to other sources of data, and or plan for the future. It's not enough to just write an application, get the functions right, see it compile, no error message, and then move on. You've got to do a lot more than that. So there was a really good session that happened just a little bit earlier. I'm going to put the link in the back of the slide, but it was from Jonas Bott about top 9 considerations when transitioning from a developer to an architect. It had some really good stuff in there on the types of things you need to learn and know to kind of add if you're moving up from a Salesforce architect to a full-on enterprise architect with any kind of developer background or wherever you started from. Great session. All right, so the science of architecture, as soon as you build it, and sometimes sooner, applications start to take on lives of their own. I've had more than one POC end up being a production application, and before I was done using it, I was getting people calling and complaining about errors about the code I was writing as I wrote it because they were already using it and needed it for day-to-day things. That's probably happened to everybody, but you have to be aware that that kind of stuff is going to happen. And as an architect, that is really your main role. It's not to worry about how quickly code's going to be adopted. It's making sure that the application's full life cycle is in your perspective. Know when it's going to be used, know when it's going to connect to too many things, do too little, how many people are using it. Those kinds of things are the planning that you should be doing as an architect so that you can guarantee the ultimate success of your project. So, and I had a coworker lay this out for me. For every $1 you spend effectively designing a solution, it's $10 to redesign it due to technical debt if not well architected, then 100 times that to completely scrap it and retool it. And then there's the damage to your reputation after a full failure and a write-off. So you don't want this to happen. You need to be doing your job as an architect, and that's planning for the things that aren't currently on the basic requirements. It's all those non-functional requirements that you need to be adding into a project. So where I'm going to try and talk is in basic archetypes of architecture and looking at the complexity of your application. So we're really going to try and focus not necessarily on the front end, but more on the back end of data. And when I've put this 1-to-1-to-1 here, it's not Salesforce's 1-1-1. This is more talking about the scale of your application in regards to complexity, calls, and data. So this is the basic drawing I'm going to use, and I apologize, this is really oversimplifying everything, but if you start out thinking about applications with writing functionality within Salesforce and connecting to objects, this is your front-end functionality. You can write a whole lot of applications that live only in this first block and for users. When things start to get interesting and when you really need to have an enterprise architecture perspective is when you start making service calls out and connecting to multiple sources of data. Now, in an ideal world, you are using small pieces of data and making quick calls one time and caching it and being able to repeatedly use that in the front end. Stuff like company stock price. You show it to every user in the company, but you only have to fetch it so often. So it's one call for multiple users. Weather, same kind of thing. You might have a couple of users in multiple different places, but the scale of the balance of users to calls is really heavily weighted on this front end where you can cache it and the complexity is low. User authentication. Yeah, I'm logging in one time. I've got to make one call out to that data store. So this is kind of the architecture, the primitives that I'm going to be talking around and comparing around for the rest of it. Hopefully this is clear. All right, so one of the first complexities that you get is whenever too many users come into your application. So here you now have an overbalance, you have a swing of application complexity and demand on the front end. And this is this is always the best problem to have. Too many users on your platform. It's really fairly easy to find solutions that scale up if you're not already on a cloud platform. So Salesforce with users, really not a problem. Tenancy, user licensing, there's some easy solutions with configurations from your account that you can do to take care of those. Other problems are solved with CDNs, load balancing, and caching. All of that really happens behind the scene on Salesforce, but it's a part of your application. You need to understand the scale of your users and what all they're consuming. Next is the amount of application complexity. This one is kind of hard to qualify, especially when you're trying to build complexity and you want to add applications. And with Salesforce, you really want to make use of your license and put as much functionality on the platform as you can. But you have to be careful when you're delivering it that you're not overloading the system, making it unsupportable, or providing too much complexity. So I've been at fun organizations where the mantra that was lamented up and down the hall was every time we update something, we fix something, we break something else. That's when you know you've gotten your complexity too high and you may want to go refactor and or divide and conquer so that you can establish trust from your users and stability in your applications. 99 record types for 10 users. The over-engineering the data model kind of per the ahead of the complexity, those are the things that you want to look out for. When your first 10 users on the system don't need all of that complexity and you'll have a mess when you try and add more to it. So plan ahead, try and solve simply first, especially for simple solutions for simple problems. So this is kind of related. Over object, trying to store too much data, trying to make your data too unique, having that complexity, losing objects, loose objects. One of the first things I do when I try and reverse engineer solve problems inside of an org is come in and look at the object manager. And if there's too many objects to discern what's going on or what's being done, it can be a struggle to manage and architect an application. So make sure you're managing your namespace and your schema and you're documenting so that you maintain a clear view of your object map. Don't try and make it a perfect twin of reality. You don't need 30 different tables for 30 different types or 30 different objects for 30 different types of users. Putting those into record types inside of contacts and so forth are kind of the solves for this. Also, make sure you have a plan to mature out of the system. So if you are putting too much data into Salesforce and having Salesforce manage data that becomes master data or related to other functions, make sure you have a plan for that data to move into another system that might be consumed. So stuff like this, if you build a sales tool and you need to actually, if you grow it to the point that you might have to move it to an item database or an RMS, a retail management system like Oracle RMS, be aware when you're designing systems that you need to have your maturity planned out. There's a great slide. I found this on Trailhead. This is definitely not mine, but Trailhead is starting talking about their data strategies because they have their internal big objects that are kind of a loose implementation of a NoSQL database. They aren't as easy to use relationally from objects, but they're a great journaling and log archiving tool. So here's a nice a flow diagram or decision diagram on how to decide what types of object and where to put your data. And this is just between objects and big objects. So if you go back to where we're looking at, that's really occupying, that's a big decision, very important decision, and it's really over here inside of this this side of the archetype that we're doing, the basic architecture. So modern connected application. So here we're looking at services in and services out of your application. You've got to manage the calls on that. This is now a networking issue. This is now a security issue. This is now VPNs. This is IP addresses. This is security. This is data leak. Sorry, when I click on that, it advances the slides. And this is everything that comes with operating across the internet. If you're connecting to data sources that are on-prem, you've got tunnels and maturity levels that you've got to have with your network infrastructure, and those can surprise you. When you're used to working in an always available cloud and you're not connected to anything, the intricacies that go into connecting to an on-prem structures, shared and managing those can be big. So you need to have a plan for how many service calls you're going to make per object, per page request, per Lightning component, how those are going to go in and when they're going to come out and whether they're compatible. So let's see, did I cover everything here? Oh, yeah, and that's where your platform API limits come in as well. Have seen big problems with applications that are being built that don't take into account how many API calls it's need to build the functionality. So anyway, yeah, MPLS, VPNs, auth tokens, oh my. So a lot of complexity can come up here. You definitely need to have that mapped out as an architect before you start building anything, especially with all the licensing considerations and extra costs that can pop up from data transfer. Now, a bigger and more modern application, this real-world data infrastructure, can have on-premises, your client, your customer, you may have lots of data marts, lots of applications, lots of file transfer, different buses, NoSQL stores, front ends, back ends, other cloud providers. All of that complexity can span multiple generations. Mainframe, you need to be aware and map out how you are going to maintain this data and what each one of these connections does to your SLA and your story of your application. If you are building on something that's broken regularly or has too many interdependencies, your application can suffer because of the complexity and the chaos that's happening in a back-end structure. I don't like to work on projects where there's not a very well-established canonical service bus and with established web services that can provide accurate and managed single point of truth for data. It gets to be too complex. Your SLA for your application becomes dependent upon the combination of all of these together, which can be terrible. So if you don't have a solid ETL system or service bus or any kind of data bus in there, this can be a problem. You've also got to work with all the teams that support them. So mapping these out, huge for architecture and infrastructure, and making sure that you know this before you start building an application. If you don't, you will be headed for a disaster. There's too many opportunities for things to fail. So moving on, reference architecture. So one of the things that you will enjoy working in, and it's not for everything, and when you outgrow the basic simple types, you'll want to start dropping in different solutions. So these are the architectures and the components that start making a really mature system usable. So you can fix some of the chaos. You can control the chaos by putting these mature structures in. And a lot of them are cloud-based, but they can't exist on-prem. And they're built for scale. So if you are looking at a project, and I know you can't, so maybe you can't see my mouse, but if you are dealing with a project that has large disparate systems and data coming from multiple places where support is a concern, you definitely want to start suggesting that all of these be moved into one of these more advanced structures. So moving your data into a data lake, consuming with Snowflake, preparing to have it consumed by Kafka, and or moving it back and forth with Mulesoft. So this is the part that we're going to dive a little bit more detail into based on this kind of a modern reference architecture. I don't like to go into projects where this kind of stuff isn't already into place. If you are building out application solutions on top of that kind of chaotic legacy systems or multiple legacy systems, this is when we're going to talk about when you are going to want to recommend putting one of these mature cloud scale systems up front so that you don't have to deal with the chaos from the old school legacy systems. So step one, dream big. Visualize the success of your tool. Don't just figure it out. And my cat's making an appearance. Please don't knock anything down. How big was the application going to get? How much data are you going to store? If you are hugely successful and the tool does everything you want it to do, figure out what's going to happen to every drop down that you have, every web service calls that you have, all of the people that could possibly use it. I've had internal tools that were used by a team that somebody said, how do we share this with the internet so that everybody can use this? That's not what we designed it for. Start building those kinds of, prepare for that. It's a big failing if somebody had that in mind and you didn't. So always explore all of those non-functional requirements or some of the eventual plans of the people who decided you should build something. Define growth boundaries with recommended changes. So it's a good idea to set assumptions and lock in non-functional kind of anti-requirements. We can build it this way for this cost, but if we have more than this many pieces of data that we try to get or more than this many users, we will have to re-architect and make people sign off on those as the kind of non-functional requirements or anti-requirements. Put those boundaries in, draw a circle around them, and make sure that you get sign off on that as part of the solution. It's not just what's in the solution, it's but can't come into the solution. In Salesforce and Apex, you can create transactional warning systems. I've written a couple of pieces of code that monitor DML statements, and if it's starting to get close to an API limit or a governor limit, I have it send an email to a set perf admin inside of the application. So prepare for those. Make developers write those in so that you can find out when this solution is about to need to cost more, or need to be rewritten, or need to move data from one system to the other because it's too much storage in one place. So always be modeling that data and planning for the growth. So that's dream big. Step 2, dream bigger. Does this data have value? What you're creating is essentially master data. You are going to be creating data. Your system, this system, will end up being the source of truth. So you may be going out and getting data to make your application work. Are you planning for the eventual need of other people to come in and consume your data? So just because you only have data out or calls out to begin with, understand that people may want your data, and you've got to provide that too. So the larger volume of data that you've got, the more likely there will be value in analyzing it. So you may be creating simple objects, but running big data reports, loading in Hadoop, or trying to figure out sentiment from customer case logs. You're going to want to pull that into an external system on a regular basis and mine that for valuable data. So figure out which pieces of data you're going to create and imagine what they could be used for. And then I'll plan accordingly. Avoid data skew. This is one that came up when I was talking to Charlie. Even within Salesforce, there's a really big gotcha that's fun and easy to define called data skew. If you haven't heard of this, there's some of the, when you're assigning large amounts of records that have lookup relationships, you can start inadvertently cause bottlenecks in performance and have a data skew. This is interesting. It's worth doing some side reading on. But this is up inside of Salesforce and the data up just in the objects. If you have your relations defined and you manage to sort data in just the wrong way, assigning too many contacts to a single account, having an other where you just dump relationships in, you can cause a performance bottleneck inside of Salesforce. And that can happen in lots of other systems. So figure out where your big data is, where your relationships are going to be, and model the size. So if an application only requires one piece of uncached data per interaction, it's 1 to 1 to 1. In the first example, company stock price, that's an easy one. So model that, and you're going to look for that snake that ate an elephant bulge in the middle, where you have large requests or trying to swallow too much data, or trying to consume or deliver too much data. So compare me looking at my company's stock price, or a single company's stock price, to that of a stockbroker. If all of a sudden a stockbroker uses your application, they're going to need data that's compiled together with history, news, and multiple other pieces of data. So even though it sounds like it's the same, the implementation, the use, or where it could go to is one of the things that you want to plan out and map ahead, because my company's stock price versus the application architecture required to go from one user with 30 service calls and 200 pieces of data, much different application. So storing objects in Salesforce is performant, but can be license expensive. Look for EDW solutions. So if you're moving data in and around, or if you're gathering large pieces of data, watch out for some of the synchronization strategies. Syncing into big objects is great. The connections can have a big cost. Look for external solutions. If your data is going to be too big and needs to be moved around, consider making your front-end application a query of that back-end summarized big data, and let another application that has cheaper scale options provide that data. Again, you won't probably have to deal with these until you're in the millions of records, But be aware, it's really quickly applications can turn into million record applications. So, and also look for spooling opportunities when data is only recorded for forensics and you're never going to need reports on it, or you just have to have it there, log it out to another tool. Something like a data lake or just a log file retention, something that you can push off and you don't get charged for over and over again for storage. Especially when ETL, bringing data into Salesforce and trying to perform ETL on it inside of Salesforce, probably not the best place to do that. So keep those things in mind, figure out if you're going to be creating data that needs to be crunched, manipulated, and or would eventually need to be able to be mined and or have reports cubed and so forth. So look for those opportunities. Don't bring it in just to perform calculations on it. So when to use API orchestration. So these have become important, and it's really nice to see Salesforce making strides in acquisitions in these larger, high-scale applications. It's fun to build stuff just inside of Salesforce, writing flows and process builders and a little custom code here and there, but keeping declarative. But when when you're crunching that data, when you're having to rely on it, you need to have a stable system for that. So, sorry, I got a little sidetracked there. When they're making investments like that, they're kind of proving that those fringe and accessory and connections out are really important to them, and they are buying big heavy hitter players like Mulesoft, making acquisitions in Tableau. So one thing that's you need to know when these big tools that they're acquiring come into play for your application. For all of these big names, especially the ones like Mulesoft that have been acquired, make sure that you are taking some time to learn what these tools are for, so that you know when your applications need to be scoped to include them. One of the fun things on that these ETL providers and the API orchestration is you can get into, and I was back with the services blowing up, and having too many services can be a nightmare, especially if you're going to multiple data sources or multiple web service providers. Having orchestration and being able to version those, roll them back quickly, can provide a vast improvement in the SLA and uptime of your application. It can be very hard to track down an errant web service that might have marginal support, and then you have to call the entire network team to get on to a call to troubleshoot where that data went. So this API orchestration allows you to bring pieces of data together that your application is dependent on and control how they come in, version them, and track them. So it's vitally important if your application needs to be up while the back-end systems are changing. So if you've got development teams on all these back-end systems, you need to have a merging strategy. You can kind of paint yourself into a corner with immature connection types into an application that grows, and that can be really painful. Master data and master logic. So one of the things you need to try and do as you're building applications is make sure that you are not using or recreating logic or data that is owned by something else. A simple example, and it's not a great example, is a tax calculation. If rounding is off on enough numbers or enough sales that are being done in one place or the other, you can cause a really big shortage in financial reportings. You can have reports that conflict with each other. So be aware of master logic, of logic that you're duplicating. And when you write reports, make sure that you note that this is not an exact calculation, or it's not shared, or it may be different in the the end retail system. Especially, same goes for master data. If you create master data, make sure you provide it. If you're consuming master data, Make sure that you have a scale for refreshing it, and making sure that it's constantly up to date. So product price, tax rate calculations, shipping, all that stuff that you might need to do in your application may be something that has a complex answer in a backend system or backend definition. Make sure you're respecting that, and acknowledging and finding a way to mitigate when and how to reuse that functionality or synchronize that functionality in your application. So data lake. Now, this is one of the interesting things. I was hesitant to include data lakes. They make a big difference, but they're very much tied when you're talking about Salesforce, specifically a cloud platform, integrating with on-premises data. Your organization, by using Salesforce, has already at least somewhat committed to moving some of their functionality to the cloud. So when you're consuming data from on-premises, your company is probably going to start, and you're going to want to make use of cloud scale and eventually move data up to the cloud and consume it from there. So if you're writing an application that is consuming data from on-premises, you're eventually going to need to rewrite that application to consume it from a cloud location. So be aware that it's probably a good time if you're talking about consuming really important data, and it's on premises, if it's in Oracle or any other system that is making a cloud move, you'll want to possibly push a data lake concept first so that you don't have to rewrite your application. It'll save cost and reduce the technical debt with the application and put it up at the front. Sometimes it's a lot easier to do that stuff ahead of the game, and you don't have to come back. So you'll see more and more of these legacy on-prem hosted applications want to move to the cloud. So everything you touch on-prem, consider whether it's time for that to move to the cloud. So data lakes let you store that data. It's usually, they can be cheaper, have versioning, and be one central location for all places, all consumers to gather the data. So you move your source of truth off of the backend application, the data mart, and you make use of that scale. But a lot of the performance and scale and cost for data lake has to do with being able to have it on the cloud and or have it readily consumed by other cloud providers. So Snowflake, again, what is the data? What is the future of your data? If you're capturing data about products, consumptions, purchases, what people are buying, that information is vital to marketing. Now, if it's big enough, if you're generating enough of it, all of your traffic on your site, you're going to want to be able to move that someplace and be able to run complex reports on it. Tools like Tableau, Click, all big data consumption. Snowflake is one of those cloud providers that can handle the heavy load of reporting and compile reports so that your application is not tasked by reporting data from the same database that people are using to put data into it. So consider if your data is going to have that kind of value and you're going to need to write really complex reports about it, or you think that will have value, start looking with an offload plan to push it into an ODS like Snowflake. This is where your Tableau report writers, you can start offloading that work, and you want to pull in the higher powered reporting tools, and your company may already have them and be able to use them and pull them from there. So that's a skill that's ramping up, and Salesforce has obviously made investments in Tableau as well. And so that will continue to be something that as you are trying to build cloud scale applications, these are the tools you'll want to have. Reports, dashboards built into Salesforce can only do so much before you need to move up and move on with real-time processing. So you can put those compute, all of that for report building, and load that into Snowflake. There we go. So I didn't put a forward-looking statement at the beginning, but all of these things that I'm going over are subject to change a lot in the future because of investments in Snowflake and Tableau. So it's a really good time to start learning it. It is a very good time to start paying attention to these technologies and seeing when to use them and start using them early and often. Salesforce would not have made these acquisitions if they didn't consider it key to their strategy in building applications and serving their developers and solution goals. So if you continue to grow your Salesforce investment, these things will come into play. And if you're looking at different products, and that's the hard part, you can no longer really consider, you'll want to lend extra weight to the ones that are going to be native to the Salesforce environment. There will be more native Tableau, there will be more native Mulesoft, and more native Snowflake. So it'll be easier, and that may tip the scales for these vendors that are being brought into the fold. So just be aware of that. Check and manage the purchases and the directions your organization is making with regards to these. All right, that is all. I'm going to, in future series, dive in deeper to these topics and some other more specific reasons of when data will be too big. But this was really an overview, just talking about the shapes of things and how you should be looking at your applications to make sure that your architecture is complete and will work and won't crater under any kind of load or mild changes to the scope. So let's see. Let me look at questions. Hopefully the cat's not attacking me anymore. Archival strategies from a large organization point of view. So please suggest archival strategies from a large organization point of view. There's too many to count. Unfortunately, a lot of licensing for all of the main players that I could name. Things like Splunk or just offlining data into Hadoop or stores that way, straight to logs. It really depends on how often you're going to need them, reuse them, or access them. So unfortunately that's one of those it depends. The other question, let's see, and this is just in the chat. I don't know if I haven't looked at the QA. Please advise when to use and not to use big objects. So big objects, really, you want to start looking at them as archival data when you're storing history. That's kind of the primary use that Salesforce makes for them, is a logging or history tracking of events that have gone on, stuff that's not going to be, stuff that makes a lot of noise, version notes, versioning type changes, small changes, iterative changes, tracking stuff that you have to keep for compliance or other reasons, forensics, but you don't probably need to ever use. So anything that's going to rack up, you might consider moving those to Splunk, but even Splunk has storage concerns and costs, and then journaling them off to other journaling systems. So big objects are still kind of limited in what they can do from a relational perspective, and I'm looking forward to seeing what they do with them and make them more powerful. But right now they are really just about logging and kind of acting in that NoSQL eventual concurrency, eventual accuracy, and not necessarily something you can build anything that needs to be right immediately. Look up NoSQL, and you should be able to see some of the main features of NoSQL and compare that with some of the features of big objects, and you'll find that they line up pretty well, and you can get some more detail there. Let's see. Let me hit the Q&A. I think I covered. So with the data lake, is this where the data master would live for a particular data type? No. Usually the data lake is where copies of data live to be distributed to other applications that need them. If you're creating master data like sales and that needs to be consumed by another organization, you might dump that into a data lake, where you might be pulling other data from a data lake to make use for your application, so that your requests for the loads are separated from the applications using and creating the data. You don't have to deal with real time. You make very raw exports of the data, and then it's managed for how you share it from the data lake. Did Salesforce buy Snowflake? No, and it's kind of fairly recently that they made an investment in it. I don't have a whole lot of the details on it. Can Heroku act as a data lake? Yes, Heroku's a platform as a service, so it could. I know that the main providers that we've worked with at SimsCorp are Amazon, GCP, and Azure. I haven't asked around. I don't think we've done anything with Heroku. When sequence important in data loads, accounts first before contacts is a good idea.